Hey there and welcome again. In this video, we will perform a hands-on lab on NAT Overload or PAT. But before jumping into the lab, let's have a quick review on the topic. The type of translation from which NAT became famous for is called NAT Overload or PAT, because it uses source port numbers alongside source IP addresses for mapping onto a single public IP address. This is possible because of the wide range of random source ports clients can generate for each session, making each NAT session distinguishable from the other. This type of NAT is used almost everywhere for internet access, in your homes, your office, etc. from multiple devices utilizing a single public IP address. In the description of the video, I have timestamps, so if you want to go to a certain part of the tutorial, you can click on the timestamp and it will go directly to that part of the tutorial. And if I go too fast or too slow for you, you can adjust the speed of the video over here. If you have any questions or feedback, feel free to leave a comment below this video. Let's get started. Hey, welcome to the lab part. Today's is the first lab of this series and I'm really excited. The lab that we're going to be doing is of NAT Overload or PAT, which stands for Port Address Translation. And the lab that we're going to be performing is going to be on Packet Tracer. And this specific file is going to be available in the description for you to download. And if you're watching this on our website, it's going to be available in the downloads area. And just a heads up, if you're curious about the icons that you see, they're basically customized icons that we're using. So for your lab, they may be different because you have to change the icons if you want them to look like this. Alright, just to give you an overview of the lab topology, we have our router, our NAT router on the left side. We have our switch, we have two PCs, and we have one internal DNS server with us. So we just got this kind of a topology of our corporate topology, you could say, on the left side, as you can see. Now the PCs already have IP addresses configured on them, and there are defaulted to .254, that is the NAT router. And they also have a DNS configured pointing towards 192.168.1.100, which is their internal DNS server. Which we will be using to emulate a website of drnetworks.net. So they're gonna be resolving that domain name to an IP address from this DNS server. It's kind of not that important, but I'm just doing this for fun, literally. Now the switch you see in the middle is literally unconfigured. It means I haven't really configured any port of that switch. So every port is in VLAN 1 by default, and has been configured, has been auto-configured as static access. You could assume that every port that you see here is an access port. The best practice would be that you should configure them statically as an access port, all of these ports that you see. If you're going with this design, that would be the best practice, but I just left it loosely. I'm not doing any kind of inter-VLAN routing here, so you're not going to be seeing different VLANs being communicated or being NATed. You could do that if you want in this scenario. So you could make this router a router on a stick if you wanted for different VLANs to communicate over the internet. That can be done, but as this lab is for beginners, I mean, this series is for beginners of NAT, so I'm just going to make it really, really simple for everyone to follow. Now coming to this cloud in the middle, I have this ISP cloud. Now it isn't actually a real cloud. Once again, it's just an icon I have created. And the main thing behind all of that ISP is just one router. I'm trying to emulate internet service provider or internet to actually emulate the web services that I'm going to be running on a web server. So in reality, it just has some interfaces configured, two of them to be really precise, one on this side, left side, and one on the right side, connecting directly to the web server that you see on the right. Now on this web server, let me just show you. I only have only have some services running on it. I have an IP address obviously configured. Let me just show you that. This is the IP address. This is a public IP address, obviously, with /30 subnet mask, and .2 is a router's IP on its side, and there is no DNS server. So okay, that is because it doesn't need DNS resolution. So that is why I haven't really configured it. Obviously, it's a demo environment, so in the real life, you will have a DNS server. The services that I'm running are only HTTP in this case, and just a little bit of code that you will see is this is the code of HTML, and this is only saying that okay, show this image which I have uploaded on packet tracers on this specific server, and they're just a welcome message saying welcome to Dr. Network's website. That's pretty much it. If you go back, there is the I think it was a logo. Let me just check that. It was the DN new one. So this is the image that they're referring. I don't know if you can see it right now, but you will see it in the lab. I'll show you once we hit this web server with the web services. Okay, to start off, we're gonna start with these lab guidelines that you see below. First of all, it says configure IP addresses and routes for NLRI. Now that stands for Network Layer Reachability Information. Now everything on the left side that you see, my corporate side, only the NAT router needs to be configured. Everything else is already configured, and it's pretty much simple. I mean, I just told you the switch is unconfigured. The PCA and PCB have only IP addresses and DNS server settings, and there is one DNS server I would like to show you. This is the IP address of the DNS server and everything. Let me see if DNS servers are running. This is the drnetworks.net a record that is stating that if anyone wants to resolve drnetworks.net, it will be resolved to that IP address, which is 182.10.10.1, which is the IP address of this web server on the right, which hosts drnetworks.net. Now, without wasting any further time, let's just configure this NAT router. For some reasons, I don't know why I'm hovering over this and it's not showing me the interfaces. It did show this before. Even if I use this magnifying lens, it's not working. So we're gonna have to find another way to do that. Well, so okay, let's start our router configuration. First of all, what we're gonna be doing is hitting enable, going into the global configuration mode and setting up a host name that's going to be NAT_router. I'm going to make that short. Okay, it has actually two interfaces, but it shows three interfaces. I don't know why. So let's go into gig 0/0/0. I'm going to no shutdown interface. Let me show you what I'm doing right now. And gig 0/0/1, I'm going to no shutdown interface too. Now this is only for packet tracer that I'm doing this. Actually, it is a kind of bug or something. I don't know. Okay, I just no shut this. The last interface that I no shut was gig 0/0/1, and I think because of this spanning tree that's running, it takes 30 seconds. So it's kind of took almost 20 seconds right now. So I'm assuming that gig 0/0/1 is connected to this switch. But if I want to be really sure in packet tracer, so I do a show CDP neighbor, and oh no, okay, gig 0/0/0 is connected to the switch. So because of the CDP neighbor, I can see that. Okay, going to global configuration mode again, interface gig 0/0/0. First of all, what I wanted to do is configure IP addresses and routes if needed, because remember from the last lecture that you do need routing in place before NAT takes place. So configuring the configuring the IP address as 192.168.1.254, one IP address 192.168.1.254, 255, 255.0. No shutdown interface, and sorry, again I have to go into the interface gig 0/0/1, and this is this interface that you see at is 200.1.1.1/30. So it's going to be IP address 200.1.1.1 255.252. That's /30 subnet mask. So it's only no shot, but I'm just, I have this habit of doing a no shot all the time. So just to check if my LAN side, as you can see here, is pingable now, it's reachable. Let me try to ping at PC 1.10. It's on 10 IP address. One packet must go for the ARP to take place. Now that is working. Let me check with the 20. That's working as well. Check with the server that I have inside of the DNS server. So it's running. Everything's working fine. And let's check the WAN side interface if it's working. 201.2. And it's gonna do an ARP again. Okay, so everything working fine in terms of segment pinging. So now it's time for NLRI. So if I do a show IP route, I don't see any default route. So that means when a PCA sends a request that it wants to reach 182, I don't really know how to get there. So what do I need to do is I need to add a route. It could be for 182, but in general, if you have this running in production in an office or a home, you're not going to do that for a specific route because IP addresses on the internet could change. So we're going to have a default route as we normally do in our homes and businesses and everywhere. So to do a default route 0.0.0, so any go to 200.1.1.2. So anything I don't know about, any route that any destination route, to be really specific, any destination route that I don't know about, I'm going to send it to my ISP's gateway. So let's try to ping 182.10.10.1. There should be a drop. Okay, there it is. So it's pingable. Now you can reach it. But obviously, the 192.168.1.0 subnet is a private IP address. Now, it cannot be registered on the internet, so we cannot do routing for it. So we're going to have to do NAT for it. So before we do NAT, we need to define the IP addresses, or specifically the private IP addresses that will be subject to NAT. And that is done via an access control list. So for our lab, we only have one subnet, but you could particularly have hundreds of subnets. That could be the case. Let's just configure an access list, and that will be an access list, a named access list. That's what I love to create because you can distinguish between them. So now there's a big question that do you need standard or extended? In my career and my experience, always extended is much better. That is because of NAT exemption that takes place later in your environment when you have tunnels and stuff, and you don't want specific subnets going to specific subnets being NATed. But that is an advanced topic. We'll take care of that later. Extended. So the word for it would be internet. I'll just make that. Okay, to match IP addresses, you have to permit those IP addresses in the access list, and the ones you don't want to match, you deny them. Permit IP. Okay, remember from lecture number 2, I taught you something that the IP protocol is really important, and it has these numbers, and then TCP UDP has port numbers. So this is actually that concept over here. So when I say IP, it's all the IP protocol numbers, TCP and UDP included. So our source IP addresses, the private IP address will be 192.168.1.0, and this is gonna be the wildcard mask, and its wildcards are obviously inverse of subnet masks. That would be 0.0.0.255. That's the inverted version. And I want to say, okay, going to any destination. I'm not specifying any specific IP addresses. I could do that, but in real life, you particularly don't do that. You always configure any, because people can go over the internet towards many IP addresses that you won't know about. All right, there is an implicit deny at the end, so you don't really need to specify denied IP any, but we'll just do that. So let's check our access list. Has it been configured? Okay, so this is the one. So the ones that are permitted are going to be matched, are going to be subject to NAT. The ones denied won't be subject to NAT. So that's the only difference. I'm not denying the IP addresses altogether. That normally happens when you apply such an ACL on an interface. Okay, the ACL has been configured, defining the private IP range in our case, which is 192.168.1.0/24. Now it's time to define the NAT inside and outside interfaces. So the NAT router won't know it by itself that which devices reside on your inside and which devices on your outside. So we have to define that. So let's go into global configuration mode, and it's pretty simple. As you can see here, oh man, there is no integration. Let me just write that down for gig 0/0/0. That is this interface. It's not looking pretty, but still, gig 0/0/1. That falls here. So gig 0/0/1 will be IP NAT inside, so it will be the inside interface, and the outside will be gig 0/0/1. So I'm going to go to interface gig 0/0/1. IP NAT inside is the command, and I'm going to go to inside. Oh, sorry, gig 0/0/. Oops, I just made a mistake, didn't I? Oh, I just made a mistake. Gig 0/0/0 should be IP NAT inside. Was going to be a terrible mistake. IP NAT inside, and this guy is gonna be IP NAT outside. To cross verify that, show IP NAT, I think it's statistics, because you could have multiple inside interfaces and you can have obviously multiple outside interfaces as well. That's pretty much it of configuring IP NAT inside and outside. Okay, now that we have configured everything that we need for NAT to take place, the only thing remaining is the NAT statement that's going to be triggered. So let us configure that statement. Going into global configuration mode, I'll say IP NAT inside. Let me just put that command in and I'll show you what it is. IP NAT inside source, that is because we're changing the source IP addresses. Of which IP addresses we're going to be changing the source of? The access that we created, which was internet. Okay, we're changing that source, but to what public IP source? Well, we're gonna borrow that public IP address of our interface 0/0/1. This one, the outside interface that you see, gig 0/0/1, the IP address configured on that interface is gonna be used for the overloading. Okay, and the last bit of command is overload. This overload keyword is the main keyword because now once you hit enter, it's gonna start overloading, meaning it's gonna start doing port address translation. And enter. Now, just to give you an overview of the command again, IP NAT inside source list internet. This basically is defining the private IP source list. It's asking for the sources of the private IP addresses. Now, this bit of command is saying, okay, once you define those private IP sources, which is basically defined in the access list, so you can have multiple private IP addresses there. What you want to do, which public IP address will you use to overload? So I'm just saying that I'm gonna use the IP address configured on interface gig 0/0/1. You could obviously have a pool that we will see in dynamic NAT. That could be a case as well. But for the timing, this is the normal case. I mean, what happens in your homes and normally in all the businesses is that you're going to be overloading your IP addresses onto a single public IP address that has been configured on your modem. It could be a modem, it could be a Cisco router or any router. So this is how it's done. Now to verify if NAT is working properly or not, we're going to go to PCA. Here it is, PCA. And first of all, I'm going to see what's the IP configuration. All right, 192.168.1.10. It had the default gateway. Everything is working fine. Now, normally you would do a ping. Now, once I do a ping, you're going to see a really different thing happening on the router. First of all, let me just hop on to the router and say, okay, let me show you those NAT terminologies you have been learning up until now. Show IP NAT translation was the command. So nothing is in this command right now. No output comes out. That is because no translation is happening. But in the real life, this will be bogged up once you do this, because internet users are gonna, bog the internet right away. This is a packet tracer, so obviously no traffic comes out unless and until we do a ping or something else. So what I'm going to be doing is I'm going to do a ping 182.10.10.1. I'm going to just do a repeat count of 1. Okay, so 1 ping, it got through. So let me check the router now. Now, as you can see, the NAT did happen. This field shows the protocol. Protocol was ICMP. Now, we all know ICMP doesn't have a source port, doesn't have a destination port. It's an IP protocol. Now, a Cisco router does need to facilitate that. So how does it do it? Well, it generates these random ports that are used to satisfy the NAT router that it's doing port address translation. Now, I know it might be mind-boggling right now because you've been taught that port numbers are translated. In case of an IP protocol that is purely IP protocol like an ICMP or could be a GRE, whenever these kind of protocols come through a NAT router and they need to be port address translated or overloaded, then the mechanism that the router uses, it generates port numbers and just binds that same port on all the NAT addresses. You won't be seeing that in a TCP or UDP packet, but this will happen with an ICMP packet. Okay, but anyway, now NAT is happening. That's what we can see from the output. Now, the translation has been expired because it takes a little time, like 1 minute or something, to expire a NAT statement once a reply has come back. It's pretty much dependent on a lot of things. We'll just discuss that. Okay, so let me just first of all go to... Alright, let's stay on that command prompt. Now what I want to see is NS lookup. I just want to look up the entry of drnetworks.net just to see if my DNS is working. Now it just sent a request to my DNS server here, and it responded back to PCA that, hey, if you want to reach drnetworks.net, the IP address is this. Now, if we can reach that IP address and can resolve that IP address, then let me use a web browser and go to drnetworks.net. Bingo! So there is my website. Pretty cool, huh? So as you can see, now I have a connection from PCA to drnetworks.net on the web server that is on 182.10.10.1. Now let's look at the NAT statements now. Beautiful. Now I have those addresses that you've been seeing for a lot of time. First of all, inside global, obviously it was the IP address that generated the packet. That will be 192.168.1.10, which is the private IP of PCA in this case. And then it has been translated to 200.1.1.1, which is the IP address configured here on this interface, the .1 being my router. And here is the port number that it generated. The source port number that it generated off the bat was 1025, and the same port number was mapped to the public IP address as well. As you can see, these are same, so the NAT table recognizes this NAT entry for PCA. Now, the outside local and outside global we just discussed in 2 lectures back, I think in lecture 3, I guess, that they're gonna be same 99% of the time unless you do destination NAT. So as you can see, 182.10.10.1 is the local and global outside address, and the port number is 80, which is the well-known port for HTTP. Now let's look at PCB. Let's try to, I think I don't need to try NSLOOKUP. I don't need to even try the ping. It will work, hopefully. Let me just try to open a web server now. Try to show you something that works. .NET. Oops, sorry. Doctor. There it is. So PCB can also access this website now. Now here is the moment of truth. Right, this is what I wanted to see. Just glance at the inside the local address. You see that both PCA and PCB generated the same source ports, but take a look at the source ports that the router mapped against its public IP address. That is what a router does when it sees overlapping ports. So that way it can maintain a separate NAT entry for each one of the clients for each session. Now typically a router would use the next available port to map. As you can see in the last entry, PCB generated a source port of 1026, which was already in use with PCA. The router mapped it to 1027, but PCB also generated 1025, which also overlapped with PCA. But in this case, the port number chosen was 1024, and that is because this specific router has a port range ranging from 1024 to 65,535. Now typically we aren't really concerned about what ports the router maps it to. That is because we're not really concerned about the source port at all. We're normally concerned about the destination ports. Well, I hope that you have enjoyed this lab, and I want you to do this lab on your own. And if you have any issues while doing this lab, or you have any ambiguity, like you have any queries or anything, do feel free to contact me. My email is ahmad@talkingnetworks.net, or you could post your question in the comment section if you're watching this on YouTube. Well, I hope this has been informative for you, and I'd like to thank you for viewing.